Hello, everyone. So we have number 20 from 2024, 12B. So we have A, B, C are the points in a plane with B is 40 and C is 42, and X be the length of the line segment from A to the midpoint of BC. So we are going to define a function f by letting f of x to be area of the triangle ABC, and the domain of the f is an open interval of P to Q. The maximum value R of this function will occur at x equals S. We want to find those P, Q, R, and S sum. Okay, so it's slightly confusing to like kind of understand what's going on. So let's see what that looks like. Okay, so the first thing, we're given two sides, and then A is the common vertex. So maybe we can start with making a pair of rays, right? So let's say this is A, and I don't really know how that looks like, but for now, I'm gonna just make two rays. Now we are gonna change it if we need to. So let's say this is A, and then let's say this is B. You may even place this on a like coordinate plane because that usually helps with the circles since we are finding some sort of like range of the third side. So that might be a good idea. But for now, I'm gonna leave it for this way. So let's say this is B, and then this is C, and then this is given 40, and this is 42. And if I connect the B to C, right, and the midpoint of that BC will be connected by the line from A, right? So that is given. So this guy is the same as this guy. So, and then we are told we are going to have a function that will give you area of the triangle ABC, but the function will be written in terms of x. X is the length of the line segments from A to midpoint, which means this guy would be just our x. So the area of this triangle will be written in terms of x, basically. So if we can find a relation between x and the area of this triangle, that will be kind of the goal. But we know we could have like a lot of different numbers for the BC. So because the Pythagorean, like not Pythagorean, but triangle inequality satisfy a lot of different numbers. So maybe we can start with that. But the problem is we need to get a range for the x, right? So we know the range for BC, but we do not know the range for A to like this midpoint. If I name that M. So we need to find the largest and smallest value of x. So one of the things we can try, maybe I'm gonna just write right here, is like we know we use the similar triangles to get the angle bisector theorem. So by extending the angle bisector, so maybe we can try such a thing in this case as well, because that will make good relation between the given two numbers as well as the mid segments, right? So let's try extending AM. So if I extend this AM in a way that will continue a bit, and then we can draw a parallel line from point like C, touching that in that line at some point, which will be parallel to AB. So if I do that, so I will get something similar to this. Okay, so this is a point C, and then this is the intersection of those. We draw that line in a way that these two guys are parallel. So the good news is, since this was a midpoint, the M was midpoint of this, the triangle right here and the triangle right here is similar, and the ratio is 1 to 1. So if this is 40, so that will make this is also 40. So C to T is going to be 40 as well. And then C, like AM to MT will be equal. So that means this is also X. So now we can write the triangle inequality in ACT. So the 2X is one side. So this has to be in between the sum of the other two sides and difference of the other two sides. So we are going to say 42 plus 40. And then 40 minus 42 minus 40. So like the triangle inequality doesn't really says the difference, but if you just keep adding, subtracting stuff and write that sum is larger than the third side. So you can actually see the absolute value of difference is going to be smaller than the other side as well. So that will be 2 if you take the half of the inequality. So you get 1, and that is larger, like smaller than x, and x is going to be halfway through like 41. Okay, so that means the x is in between 1 and 41. So we actually done with these two. Okay, so p is the smallest x value is 5 because the function should be written in terms of x. So the x is the least number is 1, and the largest is 41. Okay, so we got that. And what we want also, so this is 1, and this is 41. So we want R and S. What is R? R is the maximum value of the function. And then S is when this is going to happen. So like, remember, like whenever you are trying to find the area of a triangle, we have a lot of like area formulas, but one of them is just the area of a triangle by the side. So let's kind of remember that. So if I have, this is the alpha. So if I say this is A and this is B, the area of the triangle is 1/2 times A times B times sine value of that angle, right? So like if angle is like 90 degrees, sine 90 will be 1. So as long as we have an angle that is lesser than like 180, because the alpha is just one of the interior angle, then the largest angle we can like choose to make the sine value be largest is 90 degrees. So in that case, this guy will be 1. If alpha is 90 degrees, the area will be just A times B over 2. And this is the area of the triangle when the alpha is 90 degrees. So meaning that when the triangle is a right angle triangle, that will give us the largest area. So meaning that if the angle right here, A, is a 90 degrees, then the area will be largest. So then let's draw that slightly kind of different. So like assuming, not assuming, but based on that reasoning, so the area of the triangle will be largest if this is like 40, and then this is 42, and this is 90. And we want to find the largest area, which is going to be R. So that is kind of obvious. So 1/2 times 42 times 40. So we can take the half of this. So that should be 20. And this, which is 840. So the area is 840, which is the largest number. And the question is, what is S, right? So the S is the length of the segment when this happens, which is basically we need to know what is this red segment, which is our median. So if you look at the numbers, like we have 42, 40, so like we have actually 20, 21, and 29, a triple. So that's another triple we need to know. So if you double this, you get this guy as 58. So I can just take the half. So that should be 29. And this is also 29. But another thing we need to know, when you draw the median from right angle to the midpoint of the hypotenuse, those three will be actually equal to each other. And that is also 29. And if you kind of not convinced, you can always say, like, we have a right triangle, and then you can draw a circle around this triangle going through those 3 points. When you do that, so the 90 degrees is facing towards a segment that needs to be diameter, so which means the midpoint is going to be center of the circle, so which is why this will be also the radii of that circle. So that's why that's 29. Anyway, so we have 29 for S. So if I add this 29 to this, that's 30. So you got 71 plus this, it's 840. So that looks like 911. So it was quite interesting problem because we are relating triangle inequality, a function, a like trig somehow involved. So, and then we use Pythagorean triples, so, which is good. So, but I hope that you kind of are like convinced, but this is actually a good question. I kind of like this problem. Anyway, I'll see you in next week.